Okay.
So, do-it-yourself resistor wheel sets, okay? Mostly for occupancy detection. Why do we want to do it? Well, it's less expensive. You can buy commercial wheel sets with resistors in them, but they're about $1.50, or they're over $1 an axle, okay? Do it yourself, you get it down to 62 cents, including the postage and handling. Okay. You have a much broader choice of wheel sets and what era and what types and styles and sizes than you can get commercially. And you can, when people have block detection, as soon as the engine enters the block, it signals the next block and the block behind and all this stuff. And well, the thing about the block behind, right? Not always, depends on the length of your train, okay? Whether you're going to unblock 2 blocks behind you or just a block or just the block behind you. Okay. So you can use the last car as an unblocking signal if you want to, okay? If you're in a push situation where you're actually using your engine to push cars, right, you might wind up, if you're using just your engine for detection, you're pushing your cars into a siding or whatever, and the detector never knows it because the engine never enters the siding. It's just using to push into the siding. So you can, it's good for that. Plus, you can get control over the sensitivity that you had depending on the size of layout and things like this by choosing the resistors that you want. Okay. So, materials. You're going to need an insulated wheel set, all right, and we'll talk about what they are and how to be able to find them. You're going to need some chip resistors, all right. These are really, really tiny, okay. And you're going to need what is called bare conductor electric paint, okay. That's what this stuff is. You can actually make circuits out of this stuff. It's amazing. No soldering. No little soldering iron, nothing. You don't need any of that. Sorry, Mr. Solder. Okay? So your insulated wheel sets, okay? You notice the insulating hub, right? So this is basically a metal wheels, right? And one of them is sweated directly onto it's a temperature fit. They chill the axle and they heat the wheel and they put it on. It comes back to room temperature and they seize on each other. And the hub over there. Now, this wheel here on an insulated set is fixed to the axle, right? That one over there with the hub on it is also the one that you use to adjust gauge with, right? So don't go holding on to trying to twist this one, okay? You can twist the insulated one, move it in and out in order to get your correct gauge. So because we're going to attach something between that and we're going to jump that insulator, you better have your wheel sets set to the right gauge before you go through this process. Because if you go to twist it, you're going to break the bond between the resistor and the axle and the wheel. Okay. An interesting thing, you notice that the length on this thing is 25.4 millimeters. That happens to be this brand. It's 1 inch. Okay. I was in a conversation with a bunch of people online. Man went and he put all new wheel sets on his existing truck frames, got rid of all his plastic wheels, and he put on insulated wheel sets, and then he had derailments all over the place. Why? Well, we asked him what kind of frame he was using, right? And he had all KD wheels, right, which are very nice, right, but very old. Well, KD wheels, KD side frames are built, the hole and the bolster across it, are built for 1.14 inch axle length. Okay? So the points, instead of the points riding close up inside the socket, the points were a little bit shorter. It's only 8 thousandths on both sides, but that's twice as thick as a piece of paper. And that wheel can wobble around in there, causes derailments. Not only that, it can move this way as it goes through frog points or goes through switch points. And that's what was causing the derailments. So you have to consider when you're going to replace your wheel sets, exactly what the total axle length is. There's an NMRA standard for that wheel. It's called RP25, recommended practice. Okay, there's a specification for the distance between the wheels, and I don't remember which practice that is, right? But there is no NMRA standard or practice for axle length, none. Okay, that's why you have to be careful and watch it. Okay. Chip resistors. These happen to be 80-20s. You're going to see that if you look up chip resistors, SMA, surface mounted devices, SMDs. You're going to see those numbers like that, 80-20. What does that mean, right? Those are sizes, right? So this one here is 0.8 millimeters by 0.2 millimeters, right? Tiny, 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 and here they are. Well, what are we basically going to do? What we're going to do is we want to jumper that resistor between here to this wheel. Okay? Depending on the manufacturer of these wheel sets, that hub, that insulating hub, can be different diameters. How much it sticks out, the shoulder, also changes. Okay? So you have to be able to choose a resistor, right? That's the right size. Okay? Now these things, you can get these things that are 100 or 1 millimeter, right? 1 millimeter by a half a millimeter. Okay? So that's for more distance in between the shoulder but these fit for me on the wheel sets that I bought. So I bought 80-20s. 10K ohm is good because at HO DCC voltages, what are we going to pick an average as a DCC voltage? 14, 15. How about 15, right? Well, 15 divided by 10K, right, is 0.15 milliamps. Okay, so you're not talking any power here. Now, if that's 0.15 milliamps, right, I squared R, well, I squared is going to be a real tiny number. So these things, by the way, the 80-20 size happens to be about 1/10 of a watt, and you're going to be way below that. All right, so this one's fine. All these things that you have to consider. And here's a close-up, right, of this chip, and it's on this tape, right? And I took that close-up with my handy-dandy little phone, believe it or not. And what I did was I had my crab that had a magnifying glass on it, and I mounted that, and then I put the phone and zoomed it up all the way. And you can see that it says 1002. Well, that's 100 with 2 zeros on it, okay? And that sure is 10,000. So this information might not be fully correct. Here we go, looking at it here. Okay. So what are these things? Okay. These are composite material, and they have 2 end caps on this composite material. Right. The end caps go all the way. They wrap the edge or the sides, goes all the way around, which is very good, okay? And this is, it's tin over nickel is what it is, so you can solder to it. Actually, you're soldering to the tin, but I'm not going to solder. That's too small, right? And I don't have a wave solder machine or infrared this or whatever they use. So we're going to use electric paint, okay? Bare conductor electric paint, okay? This stuff is a silver and carbon filled matrix. It's basically latex paint, right? It's a rubber paint. It's latex paint, and it's filled with superfine silver and carbon, okay? So, and you can draw with it, just like it says. You see that's a battery over there, right? There's a battery, and that's an LED. There's no resistor. Well, that's because the battery's pretty low voltage, and the circuit actually provides the resistance. Okay. So, paint. Well, this paint's pretty sticky and gooey. Yuck. All right. Oh, good, it's seized itself over. Anyway, it's black, it's gooey, it's thick. Okay? So what do we have to do with it? Well, we get to the tools. Okay? You know your materials, now your tools. A flush saw, right? And that's a saw, a very thin saw that has no set to the teeth, so that you can lay it down flat on something and cut with it, okay? And not scratch the sides, okay? Because we're going to take that shoulder off. All right. You need very fine riffler files. What are rifflers, right? These are riffler files. These happen to be made by Diston, right? And these things are about 70 years old. Okay, they're about 70 years old, and I'll show you. I'm going to pass these around, but we've got pictures of them, right? They come in various coarsenesses, right? Very fine point tweezers. Very fine. A very flat inking plate, a brayer roller. This is a brayer roller. It's used by printers, block printers, in inking. And you use this to roll the ink out to a very, very thin layer on the inking plate. Then you put your block on top of it, and then you print it on a page. Okay, it's called a brayer, B-R-A-Y-E-R. And if you want to, you can use a crab with a magnifier to hold your work. You know. So there's the flush saw. It has, notice that there's no back on it. Okay, what do I mean by back? Okay, this is the back right here. The back does not extend down the saw. Right? So this is 3.5 mil stainless steel, okay, which means it's going to be very flexible. All you got to do is hold it flat. It is a pull saw. You can almost see that by the teeth are aimed backwards, so the cut is on the pull. All right, and we're going to use it to remove the shoulder on the wheel set insulator. Okay. These are riffler files. These happen to be what is called cut 4. They go all the way down to cut 6. Cut 6 is very, 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 very fine. Cut 1 is quite coarse. Okay? But these are rifflers, and I've got 3 of them here, and like I said, they're made by Diston, and I'll pass them out. These belonged, right, to my father. Okay? And when he was a kid. Right, he got them from his father. Old. I'll pass those around. Okay. Tweezers. 2 big names in them is Tweezer Man and Lacrosse. You know, and I've got both of them here. Tweezer Mans, almost all of them, are very, very pointed. Right? They will stick in you. They will stick in you. If you drop them off a table and it hits your foot, right, it will embed itself right in your foot and stick right in. Those things are very, very, very sharp. Lacrosses had a slightly blunt end on them, right? So they're better for holding something. You can't really hold something with very, very sharp points sideways, right? So you have the 2 different types. and you can decide which ones you might want to use. And you need an inking plate. This is an inking plate. It's quite thick, as you can see. This is float glass. They make this by taking liquid glass and they pour it on top of in a big vat of melted tin. Okay, and tin is amazing. Water, tends to wet the sides of the container that it's in. So when you look at it real close, you see a dip in it, right? Mercury does not wet the container that it's in. So it's got a pitch to it like this when you see it in a container. Tin, which is very nice, it has a low enough melting point, which is below that of the glass, okay? And it is neutral. When you put it in a vessel, it's flat. So as flat as you can get it without grinding, right, is to use float glass, right? The only thing that it has is the curvature of the earth, right? However, like all metals, right, all metals are slightly magnetic, some more than others, right? But even tin is magnetic. That's why you do not have any glass manufacturing in Iceland or Greenland. Now, why do you think? Because that's where the magnetic pole is of the Earth, okay? And it would tend to pull the tin down into a valley. So, another item off of a page out of Smith's Book of Useless Facts. So, the brayer roller. That's this happens to be a 4-inch. This is a 6-inch. It's designed such that when you use it, this one has the finger points on it. You use it like this so that when you move it, the force vector is vertical. If you push it at an angle, you're going to push the ink out in front of the roller. Okay? If you press straight down on it, all you're going to do is mush it. Okay, which is what we want to do. Okay, so you saw your materials and you saw all your tools. Okay, so now what we're going to do is the techniques. All right, so we're going to remove the insulator with the saw and we're going to prep it. Most of these wheel sets here, like this, they've been anodized. Right, this one happens to be cadmium anodized. Okay, but sometimes you get them black, sometimes you can get them different colors. But you want to get that anodizing off because anodizing is an insulator. Okay, that's why heat sinks, one of the reasons that heat sinks are anodized. And then you spot face where you're going to mount your transistor or whatever it is on it so that you can see bare aluminum. Okay, see? All this is coming together and I see the light bulb going on. Okay, so you're going to ink the plate and roll out a very, very thin layer of conductive paint. Okay, and about 2/1000 is good. If you don't know what 2/1000 is, that's 2/1000. Okay, going to pass that around. Do not pull this on the edges. It'll cut right through your fingers. Okay. You're going to touch the chip you've got this paint on your roller. You're going to touch the chip on its ends. Okay. And then you're going to mount it on the wheel. And that's what those tiny little tweezers are for. So, we've taken the saw and removed the shoulder on the insulator. See that? Okay. And I ran a little bit of sandpaper around it there to scratch off that anodizing so it would stick. And you're going to roll the paint out till it's about 1 or 2/1000 thick, right? And sure enough, up in this area right here, you can see that's very thin. The stuff is so thick that you just find a little spot. And that was a drop. That's all that was. This is through the magnifier. All right, so you roll it out, and then you touch the, I couldn't take pictures and do the work at the same time, so on the edges, okay, so you're going to put the ink, and you're going to ink it on this edge, on the end, and then on this edge. All right, and then we're going to lay it right in there. And when you lay it in there, there it is. Okay, so you can see where the connections are being made. All right. Oops. There we go. So, the one that was done on the edge, the end of it, is sitting on the axle, and the one that was done on the very back edge now is sitting on the wheel. And you just let it dry, right? Well, does it work? Take a look. So, this is a blow-up of that, right? You see I've clipped onto the wheel here, and I've clipped the other lead on there, and there's that resistor that now reads 10K. Okay? So, kind of there's your proof. Okay, well now I want to, that's a stupid little thing to have hanging out there, and somebody might see it. I want to weather it or do it, something to it. Well, can I paint it? How do I weather it? Go ahead and paint it. I just sprayed the thing with some paint, right? And it looks horrible because I didn't do a very good weathering job. No, it's still 10K, believe it or not. I measured it again, and actually, the resistance went down a little bit, right? Why? It was 10.03. Same resistor, same wheel set. Why did it go down to 10.01? What's the solvent for latex paint? Water. Can water conduct electricity? No. Water does not. As a matter of fact, when you are making integrated circuits, you use pure water as an insulator, right? Does not conduct electricity. It's the garbage that's in water that conducts electricity. So, water actually interferes with conduction. This is after 20 minutes after the paint dried. Okay? So, the water got to evaporate, this stuff finally cured, and the resistance goes down when it cures. Okay? So, I'm done. Any questions?